Alright guys, these notes are going to be all about using the Pythagorean theorem to find missing sides. Our goal for these notes is we are going to find missing side lengths in right triangles. Remember, this is the only one that it works for this chapter, using the Pythagorean theorem. Now before we start, make sure that you have a calculator. You're going to need one for today. So if you need to pause the video, go grab one real quick, feel free to do that. Alright, so yesterday we looked at a squared plus b squared is equal to c squared to see if a triangle was a right triangle. Today, let's take a look at a little more at what you're used to using it for. That's finding missing sides. Before we jump into some practice problems, let's review some vocab that is extremely important for today. This first vocab word is hypotenuse. Remember, that's the side that is opposite the 90-degree angle, or the right angle. And it's always c in the equation a squared plus b squared is equal to c squared. I want you to remember this more than even just the big side, or the biggest side. Because it's not always obvious which side is biggest if they're only going to give you 2 out of the 3 sides. So let's go down here. We're going to do a couple examples today. I promise you this is going to be pretty easy to start off with. All it wants us to do is figure out how big this side is. Now when I find my 90-degree angle, they even shaded it for us, it's pointing right at that missing side. So again, the thing I don't know in this one is the hypotenuse. All we need to do is plug into our equation that we learned yesterday. A squared plus b squared is equal to c squared. Also, when solving, make sure that you're solving for c and not c squared. I'm going to talk more about this here in a minute. Alright, so like I said, all I'm going to be doing is plugging into this. So let's rewrite it just like we would when we do volume stuff, when we do y is equal to mx plus b, anything like that. And right underneath that, I know that I need to plug in. Now, like I said before, the thing I don't know is my hypotenuse. It's across from my right angle. So I'm going to rewrite c squared. And the other two that I need to plug in are my a and my b. Just like I said yesterday, I need to do my smallest is my a, and my next smallest is my b. So I'm going to make this one my a. And my b is going to be 8. So I got 6 squared, which is 36. 8 squared, which is 64, is equal to c squared. And again, I'm going to simplify this a little bit more. And instead of saying 36 plus 64, I'm going to say 100 is equal to c squared. So now when I take the square root of both sides, I end up getting that c is equal to 10. Now, that's the part I was talking about right here. A lot of my students, for some reason, think that 100 is the side length. Doesn't it sound a little bit silly if this side is 8 and this side is 6, for this side to be 100? So that's what I'm saying when I say make sure that you're solving for c and not c squared. That's c. Remember, when we did square roots, to get rid of a square, we got to take the square root of both sides. So not 100, but 10. All right, let's do another example just like that. I promise it's going to start to make a little bit more sense. So again, I'm just going to plug into a squared plus b squared is equal to c squared. I need to find this side, which again is right across from my 90-degree angle, if I'm looking at this triangle. And if I'm looking at that triangle, obviously the side is 8 as well, because it seems like this thing is a square. Alright, so now let's plug in. Again, the thing that I don't know, this guy is the hypotenuse, so that's my c squared. And the other two are going to be 8 squared and 8 squared. 8 squared, though, is 64, so I'm going to simplify that a couple times. And 64 and 64 is still pretty easy to do in my head. It's 128 is equal to c squared. Just like up there, though, I need to take the square root of both sides. And if I want to take the square root of both sides just to get c, I have no idea what the square root of 128 is. It is not a perfect square, so that's where I need to use my calculator. I'm going to go 128, square root. Why don't you guys try that for me as well? Alright, hopefully you're going to get something similar to me. I got 11.3, if I want to round to the nearest 10. So 11.3 is apparently this side length. Pretty easy, right, guys? So would you please flip to the next page? Pause the video. Try these two for me. And when you're done trying these two, we can go over them together. All right, hopefully that was enough time. Again, just like I did in the front, I'm going to just rewrite a squared plus b squared is equal to c squared. That's my formula. I'm going to find my triangle over here, just like I did on the second example. I'm going to find my right angle. And again, it's pointing to the thing that I don't know. So the thing I don't know is c squared. My smallest side is going to be this one, which is 7. So I'm going to make that one a. My next smallest side is 24. I'm going to try to do as much of this in my head as I can. 7 squared is 49. 24 squared I cannot do in my head. So I'm going to go 24 squared and get 576 is equal to c squared. I'm not done simplifying now. I still need to go 49 plus 576, which 49 plus 576 is equal to 625. And if I try to square root both sides, I think this one is a perfect square, but it's a little bit too big for me. So I'm going to use my calculator, square root, and I end up getting 25. So apparently that side was equal to 25. Hopefully you guys got that. If not, hopefully you see what you did wrong, and we can do number 2 the same way. So looking at number 2 again, it's pointing at the side that I don't know. So I'm going to go a squared plus b squared is c squared. I'm going to fill in for 16 squared and 30 is equal to c squared. 16 squared and 30 squared are both a little bit too big for me. 16 squared is 256 and 30 squared is 900. So I got 256 plus 900 is c squared plus 256 is equal to 1156 is equal to c squared. Square root both sides now, and I end up getting, there we go, square root, I end up getting 34. That's pretty nice. C is equal to 34. So that missing side length is 34. Alright, so it seems pretty easy. This is where it's going to start to get a little bit tougher for us, because in all the problems above, we were finding the hypotenuse, or the side that is across from the right angle. Let's take a look at some where we end up finding one of the legs. Now again, remember the legs are the two smaller sides. And just like before, remember to take the square root of your answer. So again, I'm going to try to fill out a squared plus b squared is equal to c squared. I'm going to find my right angle and see that this time it's pointing at 39. So now I'm going to take that 39 and plug it into my c, because I know that's the hypotenuse. Looking at this, it looks like 15 is the smaller side, so I'm going to assume that that side is a, and then just write b squared. Here's the thing that I'm trying to find. I'm trying to find that b. So let's simplify as much as I can, like do 15 squared and 39 squared. So 15 squared is 225, and 39 squared is 1521, is equal to b squared. And now let's solve this. This should be pretty easy for us. This is just basically like a two-step equation. I need to get rid of this thing that's not attached. And my students should know that by now. We want to get rid of things that we're not attached to first. So let's get rid of this 225. How do I get rid of plus 225? I'm going to minus 225 on both sides. And I'm going to end up getting b squared is equal to 1521 minus 225. And I end up getting 1296. Now again, that would be ridiculous if this side was 1296. What am I forgetting to do? Take the square root of my answer. So let's take the square root of 1296. And when I do that, I end up getting 36. So b is equal to 36. All right? All right. So I got one more example for us, and I want you guys to try a couple for me. Let's do this one together. Example 4. So again, a squared plus b squared is c squared. Again, I'm going to plug in and find my hypotenuse, which is 16. So 16 squared goes into c. I really don't know if 12 is my biggest or smallest, but let's just get practice plugging it into b this time, because I plugged it into a before. It really would not matter if you switched it. I can do some of this in my head. I know that 12 squared is 144, and 16 squared I should know by now, but I forgot. 16 squared is 256. Just like last time, I'm going to subtract 144 on both sides. A squared is 211. So I'm going to take the square root of both sides and get a is equal to the square root of 112, which is a non-perfect square. And if you round that to the nearest tenth, what do you get? Looking at it, it looks like 10.6. All right? So, just like before, pause it. I have a couple for you guys to try right here. Just so it doesn't get monotonous, why don't you skip number 4 and try to do this one in the back for me instead. Think you're good, try a word problem. I think you guys are going to be pretty good at this. And my hint for you is draw a picture. So let's go back, pause the video, try 3 and the one in the back for me. Alright, so hopefully that was enough time for you to pause the video. Looking at number 3, I'm going to just right away write down a squared plus b squared is equal to c squared, just so I'm used to doing that. I'm going to find my hypotenuse, and looking at it, it looks like it's 25. So I'm going to plug 25 into my c squared. 20 to me looks like it's bigger, so I'm going to plug that into b, and I don't know what a is. So a squared plus 20 squared is actually pretty easy. You should have gotten 400. And 25 squared is 625. Hopefully, again, you did that on your calculator. Minus 400 from both sides. And I end up getting a squared is equal to 225. And now when I try to take the square root of both sides, 225 square root, I end up getting a is equal to 15. So I was right before when I said that side looks like it's smaller. All right, so we skipped number 4. Let's take a look at the one on the back. So the one on the back has a telephone worker that needs to run a wire from the top of a 40-foot telephone pole. So let's draw that telephone pole. Doesn't even need to be that good. And apparently it is 40 feet from top to bottom. He measures the distance from the base of the pole to the point on the ground where the wire would be. So apparently I'm going to have a little wire right over here. And he measured it, and that ended up being 30 feet. So it says, use the Pythagorean theorem to find the length of the wire. So it wants us to figure out how long this wire is going to be. Well, what shape does that make? Obviously it makes a triangle, and there's my right angle, and it is pointing at this side. So what's the side that I don't know? Hopefully you said the hypotenuse. So let's plug into a squared plus b squared is equal to c squared. And again, I don't know what my hypotenuse is, but I do know that my other two sides are 30 and 40. So let's plug those into a and b. 30 squared plus 40 squared. 30 squared is 900 plus 40 squared, hopefully you got 1600, is equal to c squared. This is 2500 is equal to c squared, and that's just a little too big for me. So 2500 square rooted is 50. So c is equal to 50, and that wire that this guy needed to use is 50 feet long. All right, that's really it, guys. I have some final thoughts for us to do. Remember what the Pythagorean theorem really says. The square of the big side is equal to the sum of the squares on the small side. Sides. The blank is the side across from the right angle, hypotenuse. The blank are the sides other than the hypotenuse. Those are called the legs. Remember to take the square root of your answer. And last but not least, on a word problem, always draw a picture. Tomorrow's notes are going to be all about word problems, and we'll practice that. Thanks for watching.